Don't let go of it.
Finguistics is a wordplay application that we put together with Infusion, a Surface development partner, and Research Machines, an educational partner within the UK. The application is designed to work for younger children from the ages 5 up to about the ages of 15, and we have the capability to either spell short words, to build sentences across the languages English, Spanish and French, or to play maths puzzle games at varying levels.
We've got the touch, multi-user and the object recognition, and we kind of looked at those and how they actually fitted in with the applications that we were discussing. Some of them, when we looked at it further, we thought, well, actually there was no reason this wouldn't be something better that was displayed on a screen, potentially even maybe with Windows 7 when that comes out. But some of them really were very much around collaboration, which is really important in education, and also the need for touch, multi-touch, and doing away with a kind of traditional keyboard and mouse.
For a Surface project, we used loads of different kinds of media, mainly because, unlike a regular screen project, we've got orientation to worry about. So we started off on a whiteboard, which is where we start with everything, and just sketched ideas out. For prototyping and wireframing, we then moved on to Visio diagrams and PowerPoint templates and things, and then we actually sat down and cut out bits of paper and stuck our own kind of Surface-esque piece of paper and moved things around with our fingers just to make sure we figured things like orientation out properly. And from then, that's when we actually started working with actual prototyping and the design tools. It's more important to get the interaction right in a physical space before we start to worry about it in a virtual space. And certainly having a Surface unit as soon as possible is very important as well, so we can actually try some of the ideas out on a physical device. The power of using a WPF means that the developers can just sit there and actually write code and make basic wireframes based on the designs we've given them. Then we can actually go into Blend ourselves and worry about how it all actually looks and how it fits together and that kind of thing. So it certainly separates the two workflows, and then we can just check in and get the latest version, and suddenly the things we've made just work.
I was sort of expecting there'd be quite a lot of things to learn, but really it's a very natural extension of WPF. So instead of working with mouse events, you're typically working with contact events. But other than that, you're still doing captures, you're still doing basically the same things with touch as you're doing with mouse. I'd say the skills transfer over really quickly and you're up to speed very quickly. One of the main differences is really the type of application you build is very different to WPF, because you tend to build an application that's got text boxes and it's got a strict orientation, whereas on the Surface everything's 360 degrees, you can work it from any side. Yeah, it's all Blend Visual Studio just like normal WPF, and basically when you run a Surface application, it comes up in the emulator. Here we've got like the Surface emulator, and you see how my mouse is a finger. That comes with the SDK. I've actually got two mice here, so I can work two fingers on the screen, and I can resize things and twizzle them around. That's very awkward. It's a lot easier on the Surface, but it's very good for testing bits of code, so you don't really need the full experience some of the time, but you could never develop an application without actually having the Surface. I think it'd be really difficult.
So I spend half my time in Blend, half my time in Visual Studio. So you do all the kind of design aspects in Blend, doing your storyboards, building the basic structure of the control, and doing the behind-the-scenes plumbing into the rest of the game via Visual Studio. In the normal world, you have things like mouse overs and mouse clicks, whereas in Surface, there's no kind of concept of mouse over or hover, so everything's on contacts.
Obviously, the big one is orientation. You've suddenly got the kind of, you used to have a single orientation on a monitor with your up and down, but that's completely gone on a Surface device, obviously, because people can sit around any side of the table. It's not as easy as you may think. I run my simulator upside down when I'm testing stuff to make sure that that what I'm designing will actually work from a different orientation, but you can't check the sides and that kind of thing. And when you're designing on a screen, you always still find yourself designing with an up and a down, which for a text-based game like we're using just doesn't make much sense at all. So as soon as you can get onto a physical device, the better, or even putting your monitor flat and turning it around and seeing what you can do if you're using a laptop, that kind of thing.
For this project we've been using ADO.NET data services to do some of the data transfer in addition with regular WCF services. It's been a good opportunity to tie those things together and get a grip for using Entity Framework and Astoria, as was. Not every technology is for every use case, but there are a lot of cases where I can see them being used, and it's really good to understand the product so that we can actually make use of it when those things do come up.
My main task has been the admin console, which is used to remote control from
sort of the teacher's point of view. They can change games, they can view what's going on, they can put games in the queue. For the admin point of view, from actually controlling the game, we've got a WCF service endpoint running inside the service app that we talk to. And as far as data management goes, we're using AD.NET data services to expose all the various entities that we write to. The code talks to the main window for the Surface app and tells it to render to a render target, which then gets turned into a highly compressed JPEG and then transferred down the wire via WCF. So we've got a timer running in the background at the moment, so this is connected to my simulator, so if we throw that over there, you'll see that that's thrown over there.
Of particular interest to me on this project is the physics engine. So the designers very early on wanted to make sure that the spelling tiles were physical objects, were real objects, so that they would bounce off each other, they would bounce off the walls. And this is a test app I used to test some of the code that we generated for our physics engine. So we've taken a very surface style of approach in putting together a reusable layout control, very similar to the scatter view that we have in photos, for example, but actually extended that in a way that makes the objects have a physical presence and actually impact on each other. So this control allows me to add objects to it, and I've added a bunch of 3D objects in this case that can interact with each other in 2D. So I've just scattered these out randomly on the table, but as you can see I can pick these up and I can knock them into each other, and they will move around in a pretty realistic way.
In the middle of the game here we've got this thing that we call a timer control, and depending on where you're stood, it might be hard to read the numbers that tick down on it. So what we've actually got is we've got this so you can actually spin it round and see from any orientation what's going on. We've also got these user controls or avatars which are activated through using these cards. It's important to remember that one of the best things about Surface is that you can actually do this optical recognition stuff over regular multi-touch platforms. So we've got Jacob here, and say I want to move Jacob, I can just stamp him down over here or stamp him over there. It doesn't really matter where he is, I can still rotate him and things. So we'll just drop Emily on as well to make sure there's another user. So now we start the game by touching this big central button here. And you see that the stimulus control, which is telling us what to actually do, is facing the wrong way for people at the other end of the screen, so they can turn it around, and if they can't read it, they can make it a bit larger, that kind of thing. One of the important things about Surface is to give feedback straight away as soon as you do something, so it isn't like it's lagging or waiting for things to happen, which is why when you put things like your avatars down, they immediately snap to the right place, or you can move these things straight away. The other thing is we wanted to give proper feedback when you actually touch something. So if you touch something correctly, or in this case incorrectly, it gives you this kind of like instant feedback when you touch it. Or if you touch the right one, which is going to be an example of how bad my maths is, you see again you get direct feedback there. We wanted to kind of carry some metaphors over from the real world to this as well. So these tiles have actual physics properties to them, so you can bash into them and knock them around the screen and that kind of thing. Audible feedback is important because you can't use as many message boxes that you would do in a regular application. Another example of using physical objects is the teacher's card. This is like, the teacher's got like a special console that they can change game settings with, so if it's too easy they can make it hard, or if they want to change the language. So they just drop this on and they get these cards spilling out. And again, this can all be rotated, so if the teacher drops it on the other side of the screen, they can move it around. Right. Remotely the teacher can see what's going on to cover, like you say, multiple devices. When we're working with the foreign languages, it's also important to show that, and we just did that through a little flag in the corner here. Right. Keeping the UI simple as well is very important. So we had one button to start the game. We've got one place where everything's actually happening, the main kind of control stuff. Very obvious what the buttons on here do. And again, instant feedback whenever you touch something, all this lagging around thinking about stuff.
So there's a big shake-up in schools coming through the Building Schools for Future project at the moment, which looks to either rebuild or certainly remodel every secondary school and possibly every primary school within England over the next 10-15 years. At the heart of that is the ICT. So Surface potentially has huge options there where we are designing schools around learning environments. So as we mentioned earlier, talking about collaboration being important in education, some of the BSFs we are looking at, we are building collaborative spaces in them. And you could envisage that actually Surface would fit nicely into those spaces, and actually we could then build whole learning experiences around collaborative work on a Surface device. So that's really exciting and has, again, huge potential.
They're giving you if you press that will help you. I'll give you one. Right.
9. 6.
No.
9. 9. 9.
9.